I'm recording again. So we're back to the PowerPoint. So what does the large intestine do? Absorbs water, ions, produces vitamins, receives the bile salt, processes getting rid of toxins and bacterial growth. That's it. We're going to mention it right here. It's not important, obviously. No, it's incredibly important for mental health, digestive health, the health of your whole body. So stretching of the stomach and duodenum triggers peristalsis from the colon to the rectum. Sphincters control the movement and the uh, defecation reflex. If you get too full, you're going to have to find a proper and acceptable space to eliminate the feces. Key points: production of vitamin K, biotin, vitamin B5, and the large intestine is incredibly important, incredibly important. It's much more than vitamins and water, vitamin production, water absorption. There are many, many substances that are digested by the bacteria from materials we cannot digest. So we get an enormous amount of essential digestive products from the action of the bacteria in the large intestine. So food is mechanically processed and chemically processed with enzymes and bicarbonate. And when we have the fecal material remaining, and it'll be removed at the end of the large intestine. But again, it's incredibly important that all of these large food molecules and that the bacteria deliver products that are necessary for maximum digestive health, body health, and mental health. So what's absorbed? Carbohydrates, broken down by amylase, starting in the salivary glands. Enzymes split these into monosaccharides, which are absorbed by facilitated diffusion, and or co-transport. So here's a summary of the processing and digestion and absorption of carbohydrates. So we want to get starches and sucrose disaccharides reduced to monosaccharides, where glucose and other hexoses are absorbed into the blood. The processing of fats by in the small intestine, which starts with bile, lipase. So lipid products form micelles, which are little spherical structures that allow the micelles to be into the epithelial cells, and they're secreted as chylomicrons. Those are little spheres into the lacteals. So that's how the fat is going to end up in the lacteals, which the lymph system takes that and dumps it back into the blood. These chylomicrons are very similar to the micelles, the lipid structures that Moderna and Pfizer use to deliver messenger RNA, get vaccinated. So all of these chylomicrons are moved and secreted into the thoracic duct and back into the blood system. So here's an outline of the digestion of lipids, and bile salts and pancreatic lipase are going to lead to fatty acids in micelles, which are very, very small spheres, three-dimensional spheres of fatty molecules being contained so that the lacteals can absorb the lacteals of the lymphatic system can absorb the fat, and eventually the lymph and the fats in the micelles are going to be dumped back into the blood. Micelles are very small spheres of lipids, like it's a very, very small membrane enclosed by phospholipids, just like the cells form the cell membrane from phospholipids. These chylomicrons are very, very small spheres created by an outer structure or covering by phospholipids. Is the process of the production of chylomicrons, which end up being absorbed in the lacteals, which then the lymphatic system dumps those livers for continuing process into the back into the blood from the lacteals, and that fat is going to be small triglycerides that are going to be continuously processed by cells. Some will be stored as fat, converted into fatty molecules, into fats which contain the fatty acids. But this breakdown of fats is a very, very directed process to make sure that the lacteals get these relatively large molecules that make in the blood these fats for use in energy production, use in the storage to help insulate our body and to make us fat if we don't exercise enough and if we eat too many fats. Okay, proteins are broken down by pepsin. Remember, pepsin comes from pepsinogen, which is activated into an enzyme pepsin by HCl. And then there's pancreatic proteases. And these peptidases also are going to break the proteins into amino acids, which are absorbed through the intestinal epithelium into the blood. So we go from proteins, stomach, and ultimate digestion by trypsin, chymotrypsin, and carboxypeptidase in the small intestine. So after breakdown and through activity of enzymes and facilitated diffusion and co-transport, the amino acids end up in the bloodstream. A lot of ingested water is absorbed. We also absorb sodium, calcium, chloride, and bicarbonate. And once we get a high concentration of ions in the blood, the osmosis is going to allow water to follow. So fat-soluble vitamins end up in lipid micelles. Water-soluble vitamins diffuse across the digestive epithelium, and vitamin B requires an intrinsic factor to be absorbed. Okay, let's stop there. We're finished. Stop recording. Stop.